Hello, I'm Pranav. Thank you so much for this opportunity. I was reached out to for a founding engineer role at Prox, and I saw the take-home project. Thought it was pretty interesting. Wanted to give it a try and show you guys. And so this is my submission for the Vulkan Omni Pro 220 Assistant. A little bit of words out there, but yeah, I built it with Claude, custom tool use agents at runtime for every prompt. The core idea is pretty simple, kind of like what you guys went over. The welder manual has exact specs and diagrams. So I modeled this information in structured tools instead of relying only on like a RAG architecture. Claude decides which tools to call for things like duty cycle, polarity, settings, troubleshooting, and some more. And the front end, the responses stream in live, so the answer should be visual. The model will emit an artifact block, which is some HTML, CSS, which I parse and then render on the right hand side here. And so instead of just text prose, users will get relevant images from the manual as well as diagrams from this artifact component here as well. I'll run a few hard queries, but if you want to test it for yourself, I've hosted it for you on Vishal. So you don't need to download or do anything. You can test it right on your browser for ease of use for you guys. So yeah, thankful for the opportunity and excited to show you how it works. Okay, so let's try a couple queries. I'll paste in one right now that I think is a good query. I'm setting up TIG on the Omni Pro 220, generate a wiring diagram showing exactly what goes to positive and negative, where the gas line connects and where the foot pedal plugs in. Reason I chose a query like this is it's a high stakes setup task. This is where you don't want just text, you want diagrams and some multimodal behavior, such as generating images from the manual. So let's give it a go. And we will see the text streamed in. Now, a couple things I want to point out here. Currently, we're generating an artifact, and we have the manual image pages set up here. We are streaming in text data, and so right now it's still loading through with the loading icons here and here. But you can see the different types of tools the different types of agents that were used, and the different types of tools that our Claude agent was able to use to get this information, which is preferred over, like, again, generic RAG architecture. And so here we are. Okay, now you can see this artifact generated here with it. So it generates some, uses Claude to generate some HTML, CSS, and then we are able to actually have a diagram generated like this to explain what goes into the foot pedal, positive and negative, as well as the gas inlet. We have this checklist here, and we also have relevant images from the manual. So this is the sort of idea of multimodal output, diagrams here, pages from the manual, as well as relevant text. And so that is one example of how my system responds to a query that would best be served with multimodal output. All right, and now for the next query, as you can see, we have this old one, or the one that I last did, still on the screen. I wanted to then add a new query as like a follow-up query. So what about flux cord, show me the same diagram style. I chose this just to show in the video to show how a short follow-up forces the model to preserve context and still generate visual output. So we'll head on with that. And again, similar kind of idea. You can see that we are generating images from the manual like before that the user can quickly look at that are relevant. And you can also see the tools that our AI agent is calling, lookup polarity and get manual images, as well as generating an artifact. So we will wait for the text to finish streaming in for the artifact to be generated. And then from there, we can continue. So perfect. Now, as you can see here, this is the new artifact that we generated. We can go back to the old artifact if we want to, and we can jump to the latest with this button here. And yeah, we have a diagram generated here. We have our text generated here, and we also have the relevant pages generated here. And so this is just kind of showing, as well as some warnings as well. Now, this is just kind of showing at a high level that we can, maintain context and build off previous questions and queries. Okay, so quick cut. Now we're going to demonstrate some multimodal input. So we are going to showcase a photo of well porosity, and we are going to ask it, like what defect do you see, and what are the top 3 checks for flux cord? Let's spell that right. All right, and we're doing this, like I said, we want to demonstrate true multimodal input with both vision and text with decision support. So we'll send that in, and we will look at the result. So yeah, as you can see, we're streaming the text. We get relevant images from the manual talking about porosity. And showing the manual images we have here. We have the text streaming in and the artifact being generated. And then boom. We have the top 3 checks as well. So overall, obviously there's things to improve, but for roughly like 6 to 10 hours of work, this is what I've came up with for the Prox challenge. I hope you enjoyed it. I definitely had a lot of fun making it. Definitely something I'm going to keep in mind. Definitely learned a lot. And thanks so much. And so yeah, that was the demo of some queries and seeing how it responds. I just want to really quickly go over at a very high level the architecture behind this. So we'll put in a query. I already did something similar in the video, and we'll have this running. Main idea though is I'll come back and kind of talk about how this is built. So I'll go over a few of the main files that are essential to the flow. We'll start with this root.ts file here. This is the core runtime. I run Claude in a server-side tool use loop. So data access and keys stay on the backend, and Claude decides which tool to call, which I mentioned earlier. We execute it and we feed the results back. And then we stream the final response to the UI, which you saw earlier in the demo. I did this over like a single shot prompt because complex questions need multiple grounded lookups before answering. And again, that's why I chose this over a general RAG architecture. If we go to the agent here and we go to this index file, this is the tool registry. So I split capabilities into explicit tools. You can see duty cycle, polarity, settings, troubleshooting, specs, and manual images, and more. I chose narrowed tools over one giant retrieval to keep behavior more predictable and deterministic. And also this is a little bit easier to extend and improve upon. Now, let me go to duty cycle JSON here. Now, this is one example of structured manual extraction. Duty cycle is it's exact matrix data, right? So I modeled it as structured facts instead of hoping, like cosine similarity for vector search retrieves the right row. And so this gives much more deterministic answers for amperage and voltage, just like voltage related questions, I should say. I'll also go to polarity here. And so yeah, so polarity is safety critical and easy to get wrong. So I encoded socket level mappings and step-by-step steps by process. And this is why the agent can connect wiring diagrams instead of generic just text responses. And so yeah, that's essentially a high level of some of the data. You can go more into detail later. I'd like to also go lastly over the artifact render. So we can go to source, go to components, artifact render. So here at a high level, this component renders generated artifacts in an isolated iframe. So this gives dedicated visuals for multimodal output for diagrams while keeping the chat pretty readable. And so yeah, that's a high level overview. I'm happy to discuss more. I've documented it all in the README here. And so yeah, it's hosted online. Should be easy to demo yourself without needing to download anything. But I mostly wanted to optimize for deterministic results for technical correctness as well as multimodal output. And yeah, that's the overall project, and excited to hear back.